Hello everyone, welcome back to Diksha Karnataka YouTube channel, and we are currently discussing the chapter Electrostatic Potential and Capacitance. The theory revision is already done. You can go and check it out in our channel. So you have to subscribe to our channel and obviously join our WhatsApp channel to get the PDFs of all the lectures that we are doing on our channel. And now it's time for discussing all one marker. First we are going to discuss MCQ questions, and then we will be discussing some fill in the blanks question as well. So without much delay, let's start with the first question. Name the physical quantity whose SI unit is joules per coulomb. Okay, so joule is the unit of work, and if you divide work by coulomb, you will get the electrostatic potential. So it is electric potential is the correct answer for this question. Now next, spherical conductor of radius r is carrying a charge of plus q. The ratio of electric potentials corresponding to a point on the surface of the conductor and at a point at a distance 2r from the center of the conductor are in the ratio. So we have a spherical conductor. Okay, the radius is given by r, so electric potential is given by q by r, k q by r. K is 1 by 4 pi epsilon naught, and if you go to a distance of 2r, it will be k q by 2r. As simple as that. So what is the ratio between them? The ratio is 2:1. So on the surface, first, what is first? Surface of the conductor to a distance 2r. So first is surface, second is 2r. So as you can see, it is basically twice that of this, so it will be 2:1. You can find the ratio as well. You can divide them, q by k q by r divided by k q by 2r. So you will get 2 by 1, that is 2:1. Okay. Order is very important. If the same question is asked by saying that 2r is first, 2r to surface, then it will be 1:2. Okay, the order in case of ratio based question, the order is very important. Now next question, equal charges are given to the two spheres of different radii. The potential will be more on bigger sphere, be more on smaller sphere, equal on both spheres, depend on the nature of the material of the sphere. So we know that one small sphere, one large sphere, both are given same charge q. So this is small r, this is capital R. So what is the potential? K q by r. This is the smaller sphere, V1, and say V2 equals to k q by capital R. Because capital R is greater than small r, we can say that potential on the smaller sphere is bigger than that of the potential on bigger sphere. So smaller sphere, bigger potential, bigger sphere, smaller potential, inversely proportional. So be more on the smaller sphere. Next question. For linear dielectrics, the ratio of dielectric polarization to the applied electric field is equal to mobility epsilon naught into susceptibility, dipole moment, or permittivity. Okay, so linear dielectrics, the ratio of dielectric polarization to applied electric field is equals to epsilon naught times susceptibility. The dimension of electric polarization is given by, so what is electric polarization? Electric polarization is basically, so electric polarization is given by, normally is given by dipole moment divided by the volume of the conductor. Or dielectric, sorry. So dipole moment is basically, we know that dimension of dipole moment is LAT. We have learned that in our previous chapter, and volume is L cube, right? That is the dimension of L cube. So dimension of electric polarization is L to the power of -2 A into T. Okay, so this is the dimension of electric polarization. Next question, the electric potential at the surface of a charged spherical shell of radius 10 centimeter is 20 volt. The electric potential at the center of the shell is, so we know that electric potential on the surface from the center till the surface is constant. Okay. So electric potential from the center till the surface, it's constant. So if it is 20 volt on the surface, the same potential will be at the center as well. Electric potential is not zero. Electric field is zero inside a conductor. Electric potential is constant inside a conductor. The electric field at a point which is very close to the surface of a charged conductor with the surface charge density sigma is given by sigma by 2 epsilon naught. Electric field at a point which is very close to a surface of a charged conductor is sigma by 2 epsilon naught. The energy density between the plates of a charged capacitor is given by, so energy density between the plates of a charged capacitor is half epsilon naught E square. The potential energy of an electric dipole placed in an uniform electric field is minus Pe cos theta. So we know that P is vector, E is vector. So when do cos theta comes? So it is basically minus P dot E. Okay, so U is minus P dot E. Next, an electric dipole is placed in a uniform electric field. The dipole moment makes an angle theta with the electric field. For what angle theta is the potential energy of the dipole is maximum? So what is potential energy again? Potential energy is minus Pe cos theta. Remember, there is a negative sign. So when will be this value will be maximum? The value will be maximum when cos theta value is minimum. So what is the minimum value of cos theta? Minimum value of cos theta is not 0, but minimum value of cos theta is minus 1. So it will be Pe minus 1. So that is P. So when is cos theta equals to minus 1? So theta must be equals to 180 degrees or 2 pi. So it is theta equals to 180 degrees. The potential energy is maximum. The capacitance of a capacitor is defined as C is equal to Q by V, a factor on which the capacitance of capacitor depends. So this is a very good question which is actually trying to divert your attention by giving this formula. This formula is actually not relevant for this question because we know that even though capacitance is equals to Q by V, it is independent of charge and voltage. It only depends on the dimension of the capacitor, right? So charge Q, it does not depend. Okay, potential V does not depend. All of the above obviously not correct. So geometry of the conductor is the correct answer. It only depends on geometry of the conductor. Capacity of a parallel plate capacitor can be increased by increasing the distance between the plates, increasing the thickness of the plates, decreasing the area of the plates, decreasing the distance between the plates. So we know that capacitance is K A by D, or sorry, not K, as I said, K mainly for KCET exam, K will be there, otherwise it is the option. So if you decrease the distance between the plates or if you increase the area, these are the two cases. Okay, decreasing the distance between the plates or increasing the area. So area is decreased, thickness independent of thickness. Okay, so only option correct answer is decreasing the distance between the plates. So if you decrease the D, capacitance will increase, right? If you increase A, directly proportional, it is inversely proportional. So you have be careful and answer it wisely. Next question, the potential energy of a capacitor is stored in the dash between the plates of the capacitor. It is stored in the electric field. We have seen that energy density depends on the electric field, half epsilon naught E square. So basically energy stored in the form of electric field. Which of the following correctly describes the behavior of polar and non-polar dielectrics in an electric field? Let's see. Both polar and non-polar dielectrics have permanent dipole moments, but only non-polar dielectrics align in external electric field. Both only polar dielectrics have permanent dipole moment and both of them align in the presence of external electric field. So this is a wrong statement. Polar dielectrics align the dipole moments with the external field, while in case of non-polar dielectrics, the dipole moment is induced in response to the field. So this is the correct answer. You can check the other options as well. Non-polar dielectrics align the permanent, non-polar does not have a permanent dipole moment, so this is wrong. Polar and non-polar dielectrics behave identically, it is also not correct. Polar do have a permanent dipole moment, whereas non-polar molecules, they develop a dipole moment in the presence of external electric field, so option B is correct. An electric dipole is placed inside an insulating spherical shell. Pick the wrong statement. So dipole, electric dipole is placed insulating, it is not a conductor, it is insulating medium. Net charge enclosed by the shell is 0. You have to pick the wrong statement, be careful. Net charge enclosed by the shell is 0. So net charge in case of a dipole, if this is Q, this is minus Q, so total charge is 0. So option A is correct. Sphere acts as a equipotential surface. So if you consider the sphere, definitely net charge enclosed by it 0. So you can consider it to be a equipotential surface. Electric flux through the sphere is 0. So whatever electric flux, net charge is 0, electric flux is 0. Electric field is not uniform across the surface of the spherical shell. Actually, electric field is uniform across the surface of the spherical shell. Okay, because the net charge enclosed by the surface is 0, that means electric field will be uniform. So this is not a correct answer. So this is the wrong statement. Next question. The following graph shows the variations of two physical quantities with distances r from the center of uniformly charged spherical shell. Identify the graphs. So there are two graphs, graph 1 and graph 2. You have to identify the respective graphs. First graph shows the variation of E versus R, second is V versus R. So one of them is E versus R, another one is V versus R. Now we know that electric field is 0 inside the sphere, right, and electric potential is constant inside the sphere. So this represents a constant value, right. So this is constant and then it is decreasing 1 upon r, whereas this is 0, this represents 0 and then it is decreasing 1 upon r square. So graph 1 represents potential, graph 2 represents electric field. So first graph shows is V versus R and second graph is E versus R. So option B is correct. Next question, statement based question. The electric field inside a conductor is 0. Correct statement. All the charges reside only on the surface of the conductor. This is also correct. And because all the charges reside on the surface of the conductor, electric field inside is 0. So both statements are correct and statement 2 is the correct explanation of statement 1. Okay, both statements are correct, and because all the charges are outside, electric field inside will be 0. Gauss's law. Now let's see one question. An imaginary sphere radius capital R is drawn around a charge capital Q, keeping the charge Q at its center. The work required to move a test charge from A to point B. So here we have a point charge and we want to move a charge from A to B. So what is the work done? Now if you see, this is a point charge, that means this is a equipotential surface because it's a circle or sphere, whatever you consider. Okay, it's an equipotential surface because distance is same for both cases, so it is an equipotential surface. If you move a charge in an equipotential surface, the work done is 0. So work done is 0. Consider the following statements. Statement 1, the equipotential surface at a point is always normal to the electric field at that point. So equipotential surface is always normal to the electric field at that particular point. This is the correct statement. If the electric field were not normal to the equipotential surface, work has to be done in moving a test charge on the surface. So if it is not a normal, okay, if it is at some angle theta, then you have to do some work because P dot E will not be 0. So in that case cos theta will not be 0, so that means you have to do some work, and that's why it is not possible. So this is, both statements are correct, and statement 2 is the correct explanation of the statement 1. Okay, little tricky, this question is slightly tricky. You need to know a little deeper of the chapter, little bit deeper of the concept, then you can answer this question. Let's see one more question. The equivalent capacitance of this combination. So C1, C2 are in series, whereas C3 is parallel with this combination. So let's solve. C1 and C2 are in series. So what is the equivalent capacitance? C1, C2 by C1 plus C2. in series, right, and C3 is in parallel, so you have to add C3. This is the total equivalent capacitance of this combination. First you solve the series one, then you add parallel one to that. Now add this, so you will get C1 C2 plus C1 C3 plus C2 C3 divided by C1 plus C2. Okay, so let's see. C1 plus C2, C1 C2, C2 C3, C3 C4. C4 is not there, I think there is one small mistake, it will be C3 C1. Okay, C3 C1. So this is the correct answer for this particular question. In fact, you can answer this question after seeing the denominator only, right? Now let's move on to the next question. The angle between equipotential surface and the electric field is angle between electric potential and equipotential surface and electric field is always 90 degrees. So option A is correct. What is the total charge in the parallel plate capacitor? Total charge Q and minus Q. This is taken from one of your previous year question. So Q and minus Q both are equal and opposite, so total charge will definitely be 0. Total charge is 0. The capacitance of a capacitor is 6 into 10 to the power of minus 6 farad. It is connected to a 200 volt cell. The energy released on discharging it fully will be. So the voltage is 200 volt, capacitance is given. What is the energy stored? Energy is basically half CV square. So just put the value half. C is 6 into 10 to the power of minus 6. V is 200 square, so it will be 3 into 10 to the power of minus 6 into 4 into 10 to the power of 4. So 200 can be written as 2 into 10 to the power of 2 and whole square is there, so 2 square is 4, 10 to the power of 2 square is 10 to the power of 4. So it will be 3 4s are 12 into 10 to the power of minus 2 or 0.12 joules. Okay, so 0.12 joules is the correct answer. If n identical capacitors of capacitance C is connected in series, then the equivalent capacitance n capacitor. So the equivalent capacitance will be 1 by C plus 1 by C plus 1 by C dot up to n. So it will be n by C. So C equivalent will be C by n. Okay, it will be C by n. Next question. If the charge is in a capacitor is double, then the capacitance is. So capacitance is independent of the charge. So if you double the charge, the capacitance will remain the same. It will not change. Capacitance of a capacitor only depends on the dimension and whatever is you have kept inside the capacitor plates. So it is not dependent on the charge. At the surface of a charged conductor, the electrostatic field must be 0, parallel to the surface at every point, infinity normal to the surface at every point. On the surface of a conductor, electrostatic field will be always normal. The electric field inside the cavity of a charged conductor is 0. This is known as electrostatic shielding. If you remember, during my lecture I mentioned electrostatic shielding, that if you construct a metal cavity, then inside the cavity the electric field is 0. It is called electrostatic shielding. Dash dielectric develops a net dipole moment in the presence of an external electric field. Only polar, only non-polar, both polar and non-polar do develop a dipole moment. Okay, polar already have a dipole, so but the net dipole moment is 0. Okay, polar at molecular level, polar molecules are obviously they have dipoles, but their net dipole moment is 0. When you apply external electric field, they develop a net dipole moment. So that's why both polar and non-polar, they do produce electric dipole moment. Very important question. Which of the following is discontinuous across the surface of a spherically charged shell? Only electric field, only electric potential, both electric field and potential, only gravitational field. So obviously this is a bad distraction. So if you see that electric field was 0 up to the surface, and suddenly it increases and then it goes back to 0 again. So there is a discontinuity. This is called a discontinuity. The graph is not continuous. The graph, it was 0, suddenly it increases and it goes to a 0. If it was like this, then we have said this is continuous graph, but this is not there. So electric field is discontinuous, whereas if you consider the electric potential, okay, it is like this and then it is like this. So there is values are changing, but it is not, it is still a continuous graph. The graph is still continuous, there is no break. So that means only electric field is discontinuous, electric potential is not discontinuous, it is a continuous graph. Okay. Potential due to a charge Q at its own location. So I gave you this homework question, if you remember during my theory lecture. Potential due to a charge at its own location is infinity. Why? Because potential is given by KQ by R. So at its own location R is equals to 0. So if you consider a charge, okay, at its own location, this is R, right? So at its own location R must be 0. So if you put R equals to 0, you get potential is equals to infinity. It is not defined at the position of the charge. Okay. Now next, fill in the blanks. Let's see the fill in the blanks. Now while solving fill in the blanks, I always say that try to make a sense of the sentences. If it is making a sense, then that could be the answer. Not always it will be the answer. There will be some fill in the blanks where it might be difficult for you to identify whether it is a correct or not, but if it is not making a sense, definitely that will not be the answer. That's how you can eliminate few of the wrong choices. So first question, a molecule possessing permanent dipole moment is called dash molecule. So a molecule possessing permanent dipole moment is called polar molecule, right? So if you see that either polar or non-polar is not, definitely not. So the answer for this fill in the blanks is polar. Let's see, non-conducting, nanofarad, distance, polar, increases, decreases. So if you see moment is called decreases molecule, obviously that does not make any sense. Only one thing that makes sense over here is polar. So definitely polar is the answer. So whenever you answer it, try to mark it in the question paper so that you know that this option is already taken. And remember that one option can only be there for one of the fill in the blanks. Multiple fill in the blanks cannot have the same answer. The potential due to a dipole depends on dash. Potential due to a dipole depends on. So now let's see, if you don't know the answer, non-conducting obviously does not make any sense. Nanofarad does not make any sense, it's a unit. Distance makes a sense. Okay, increases, decreases also does not make any sense. Sense means sentence does not have a proper meaning. The potential due to a dipole depends on distance, it makes a sense. So this must be the answer. As the distance between the plates of a capacitor is increased, the capacitance. Now if you see this option, this is also done. Now if you see this question, there are two possible answers. Either it can be increases or it can be decreases. Both these options makes a sense in this particular question. Okay, so in this case you have to be careful. If you are not sure, you can skip that, and later on after confirming all of your doubt you can answer such questions. But here we know that capacitance is area epsilon naught by distance. So if you increase the distance, capacitance must be decreasing. So capacitance must decreases. Capacitance is measured in. So now what is the unit of capacitance? Nanofarad. Only one thing that makes sense is nanofarad. Okay, dielectrics are dash substances. So dielectrics are non-conducting substances. This only thing that makes sense. So this is how you can answer the questions. Even if you don't know the answer, you can eliminate some of the wrong choices and you can choose the correct answer. Okay, I hope you enjoyed the all 1 marker session, right? And I will be back with the 2, 3 and 5 marker questions from this chapter very soon. Till then, bye.